Okay student, now we'll see the first theorem of this chapter. Okay, if y is a differentiable function of u and u is a differentiable function of x, then dy by dx is equal to dy by du into du by dx. This theorem is also known as chain rule of derivative. Okay, dy by dx means we have to differentiate y function with respect to x, but this dy by dx is nothing but the product of two derivatives, that is derivative of y with respect to u and derivative of u with respect to x. We have to find out these two different derivatives and we have to merge them. Okay, so result gives you derivative of y with respect to x, that is dy by dx. Now, how to use this theorem, how to use this chain rule while solving the example? We'll see that in this example. Okay. Now see, y equal to root of x plus 1 by x. Okay. Now here we'll replace or we'll put u equal to x plus 1 by x. U equal to x plus 1 by x. So if you replace this x plus 1 by x by this u, so your function will be y equal to root u, because this total term you have replaced by u. So y equal to root u will be your new function now. Now y equal to root u, this u is a parameter of your function. U is parameter of your function. So we'll differentiate y function with respect to u. Differentiate y with respect to u. So derivative of y with respect to u becomes dy by du. Now we have to find out derivative of this root u function. If you remember our formula, or if you remember standard form of the derivative of root x was 1 upon 2 times root x. So derivative of root u becomes 1 upon 2 times root u. Correct? Now we have done with this function y equal to root u. Now we have to find out the second, that is u equal to x plus 1 by x. Because we have assumed u equal to x plus 1 by x, so we have to differentiate this function also. But here function is u and parameter is x. Function is u, parameter is x. So we'll differentiate u with respect to x. That is nothing but du by dx. Right? So derivative of x is 1. We have already seen this in our standard form. Then derivative of 1 by x is minus 1 by x square. Correct? So we got du by dx. Here we got dy by du. If you see, both the result gives you right side of your chain rule. Correct? What was the chain rule? dy by dx is equal to dy by du into du by dx. Correct? Now we have got both the values, dy by du and du by dx. Now we'll write them together here. Dy by du was 1 by 2 times root u. Du by dx is 1 minus 1 by x square. Right? But don't forget, u was nothing but x plus 1 by x. Right? So we have to resubstitute that. U will replace by x plus 1 by x. Okay, because your original function was in terms of x, so your final solution should be in terms of x, because we are finding dy by dx, so your answer should be in terms of x only. Okay, so this is how we use this substitution method to find the derivative of this function. Okay, getting? Hello student, welcome to our new point, that is derivative of inverse function. Before that, we'll see the theorem number 2, which is related with this inverse functions. So second theorem is, if y equal to f of x is derivable function of x such that the inverse function x is equal to f inverse of y is defined, then derivative of x with respect to y is given by 1 upon dy by dx, where dy by dx is not equal to 0. It means your denominator should not be equal to 0. Okay, so this was the second theorem. Now we know there are 6 trigonometric functions, so obviously we will have 6 inverse trigonometric function, like y equal to sine inverse, cos inverse, tan inverse, cot inverse, sec inverse and cosec inverse. If derivative of sine, cos, tan, cot, sec, cosec are exist, then obviously derivative of their inverse also exists. So let's see one by one the derivatives of inverse trigonometric functions. Okay, now see the first one, y equal to sine inverse x. This is our first inverse trigonometric function. Their derivative is dy by dx 1 upon under root 1 minus x square. Correct? This is the derivative of sine inverse x function. Similarly, we have cos inverse x. Their derivative minus 1 upon root 1 minus x square. The difference between derivative of sine inverse and cos inverse is only numerator's sign. Now next is y equal to tan inverse x. Their derivative is 1 upon 1 plus x square. Okay. Next, number 4, derivative of cot inverse x is minus 1 upon 1 plus x square. Now next is derivative of sec inverse x is 1 upon x under root x square minus 1. Next and last is y equal to cosec inverse x. Their derivative is minus 1 upon x into root x square minus 1. So these are 6 inverse trigonometric functions and their corresponding derivatives. Okay. Now we'll see the examples to how to find the derivatives of inverse functions. See student, the first example is y equal to sine inverse 1 minus x square. Okay, now we'll differentiate this function by using derivatives of inverse trigonometric function. Here trigonometric function is sine inverse, right? So derivative of y with respect to x will be dy by dx. Now we have to differentiate this right side, sine inverse 1 minus x square. So first assume that 1 minus x square is nothing but x. If you assume this whole bracket as x, so you will get your new function sine inverse x. So we know how to differentiate sine inverse x. So derivative of sine inverse x will be 1 upon under root 1 minus x square. So sine inverse x become 1 upon under root 1 minus x square. We know we assume this whole bracket as a x, right? So this we have to take square of this whole bracket. 1 minus bracket 1 minus x square whole bracket square. Now we have done with this. Now we have to differentiate this part separate. We have to differentiate this 1 minus x square separately. So differentiate derivative of dx 1 minus x square. This is called chain rule. So derivative of 1 is 0 because it is a constant term, minus sign as it is, and derivative of x square is 2x. So 0 minus 2x is nothing but minus 2x. This minus 2x will keep on the numerator side, right? And this denominator's part as it is here. So dy by dx means derivative of this total function become dy by dx equal to minus 2x upon under root 1 minus bracket 1 minus x square whole bracket square. Getting? Now come to second example. Y equal to tan inverse x to the power 4 by 3. If you see this example, you can relate this example with our first formula of the differentiation, that is y equal to x raised to n. Assume this total bracket is x and 4 by 3 that power is n. So we can use power rule of differentiation here, right? So how you will differentiate this tan inverse x to the power 4 by 3? This 4 by 3 will write before tan inverse x, right? And we'll subtract 1 from that power 4 by 3. And this base, that is tan inverse x, will be as it is here. So 4 by 3 tan inverse x to the power 1 by 3. 1 by 3 we are getting from subtracting 1 from 4 by 3, right? Now we have to differentiate this tan inverse x separately according to our chain rule. So derivative of tan inverse x we are taking separate. So the first part as it is here, and derivative of tan inverse x is 1 upon 1 plus x square. Now 4 is in the numerator. So this 4 will write with this tan inverse x, and this 3 will write with this denominator 1 plus x square. So 4 into tan inverse x to the power 1 by 3 divided by 3 into 1 plus x square. So this is the derivative of this function y equal to tan inverse 4 by 3. Okay. Now similarly, we'll try one more sum. Okay. Function is y equal to sine inverse into 2 raised to x. Now we have to differentiate this function. Again, this third example is related with first sum, right? Like this 1 minus x square, we assume it was x. So similarly, this 2 raised to x also will assume it is x only, right? So how to differentiate this? Derivative of y will be dy by dx. Now sine inverse into 2 raised to x. Sine inverse 2 raised to x. So first, assume this 2 raised to x as a x function, right? So derivative of sine inverse, we know it is 1 upon under root 1 minus x square. Derivative of sine inverse x is 1 upon under root 1 minus x square. But we know our x is nothing but 2 raised to x. So we'll take square of 2 raised to x directly. Done? Now according to chain rule, we have to differentiate this 2 raised to x separately. So differentiate 2 raised to x. Right? Now, what is the derivative of 2 raised to x? What is the derivative of 2 raised to x? 2 raised to x, this 2 is constant term and x is a variable, or you can call it is parameter also. So this is in the form of a raised to x, right? A was constant term, x was variable. So what was the derivative of a raised to x? It was a raised to x into log a, right? So here 2 raised to x ka derivative will be 2 raised to x into log 2, right? So we are done with derivative. Now we'll write the final answer. This 2 raised to x into log 2 is in the numerator, that is 2 raised to x into log 2 divided by this 1 minus 2 raised to x to the power 2. This is your final answer, that is derivative of the function sine inverse 2 raised to x. Okay.